Okay, so Eg5, using the chain rule to differentiate. So the first expression there, y equals the square root of x squared plus 1. So I can write it in index form. To the power of a half, square root becomes the power of half. But because I can't expand that bracket out, then I can't use the AS form of differentiating. But I can see that I've got there a function x squared plus 1 embedded in that second function x squared to the power of a half. So if I let u equal x squared plus 1, that is something that I can differentiate. So I can do du dx and get 2x. And if I've let u equal x squared plus 1, my original function becomes u to the power of a half. And I can also differentiate that, y, with respect to u, using AS differentiation skills. And that would be a half u to the minus a half. Once I've carried out that differentiation, I can then replace the u back in. So that's going to be a half u is x squared plus 1 to the minus a half. And then the chain rule tells me that dy dx is the product of dy du times du dx. And if you think of that as a pair of fractions, the du's would cancel, leaving you dy dx equals dy dx. So it holds together as a sort of a fraction concept as well. So dy dx is dy du, which we know is a half x squared plus 1 to the minus a half, multiplied by du dx, which is 2x. So you could think there that the 2's are going to cancel. So dy dx equals x squared plus 1 to the minus a half. And what you would usually do is if they gave you the question in index form, you would leave your answer in index form. But because they gave that as a root, we can rewrite this as x all over, because it's a minus a half, the square root of x squared plus 1. So that's mathematically correct. It's just sort of good mathematical manners to return it to the way it started. And then b, y equals 1 over x squared minus 3 all cubed. So we'd write that by bringing the power up to be minus 3. So y equals x squared minus 3 to the power of minus 3. Here's our embedded function. So we'd let u equal x squared minus 3. I can differentiate u with respect to x. So du dx will be 2x. My y function is now u to the power of minus 3. So dy du will be minus 3u to the minus 4, which will be minus 3x squared minus 3 to the minus 4. And then the chain rule, dy dx equals dy du times du dx. The more times you write that out, the better it is it's going to stick. It's not one that you're going to be provided with in a formula book. So dy dx equals dy du, which is minus 3 x squared minus 3 to the minus 4 times du dx, which is 2x. Tidying that up to put it back into the form it was given, I'm going to have minus 6x on the numerator, and then that power of minus 4 is signalling that we can write that as the denominator. The more of these you practice, the better you're going to get.